All right, so let me jump right in here. So my role, my group's role within AMD is ecosystem, and Frank and Neil both have talked about ecosystem. Hopefully, you guys all understand the same kind of conceptual what we mean by that. And if not, I'll give a real brief, my perspective. By the way, it's really hard not having the ability to move around. So forgive me, I'm going to look a little awkward as I force myself. No, that's okay. That's okay. So ecosystem to us means, companies like us make solutions, silicon that by its very nature is custom. It's there is no standard for it, if you will. And so not only the traditional ecosystem, meaning sockets and power supplies and so forth, have to be unique or customized for us. But as we go forward in time, and that's what this organization is about, that's what this talk is about, we are encouraging the industry, the ecosystem, and engaging the ecosystem to go develop whole new areas of technology, whole new industries, whole new solutions. And so for us, and specifically in my organization's focus, ecosystem means precisely that. We focus on these immersive technologies. By the way, also immersive technologies doesn't mean VR or AR specifically. Included in there, audio, traditional display technologies, any number of different things, anything that can cause or help immerse the user into the environment that they're engaging. That is an immersive technology. So with that in mind, let me move forward. Oh, that's right. I'm done. There we go. So what's going on in our industry? This chart talks to the progression over time of silicon development. And I don't think much of this will be a surprise to you guys, except I wanted to show a quick visual that says, while the ability to increase speeds more or less has reached kind of a limit, and there are certain exceptions to that, but largely we've seen over the past decade that frequencies themselves are no longer the delimiter of performance in systems. So what is? Well, cores, architectures, not just cores, but architectures. So what you'll see is not only have we seen over the past decade multi-core CPUs, multi-core, many core GPUs, but increasingly we're delivering these specialized cores, specialized solutions on silicon. Things like real-time encode and decode capabilities, real-time ray tracing, artificial intelligence engines, and so forth. So all of these are opportunities to differentiate without necessarily speeding up the solution, but rather identifying opportunities or needs in the industry and addressing those very specifically. So what I want to talk about, what I want to go through is not a convergence, but an opportunity where my talk is very specific to, the example I'm using is very specific to gaming, but I wanted to give you an idea of how a number of different technologies that many people don't realize are relevant to gaming, in truth they are. And this is an example of how I think this organization and some of the opportunities we have together as a community can be leveraged or can be identified. That is, within the gaming community today, we're seeing a strong adoption, strong interest anyway, in adopting artificial intelligence. Who here, by the way, knows what blockchain is? Who here thinks blockchain is crypto? Well, you guys are smart. So crypto leverages blockchain, but blockchain is so much more. And so blockchain as a technology does have direct relevance to the gaming community. I'll talk briefly about that. Freesync and Hdr, these are display technologies. XR as an industry in the gaming community. And then, of course, ray tracing, which for some reason I couldn't say a moment ago. So artificial intelligence. What is the value of artificial intelligence? Well, I gave one example here. There are very, very many. And by the way, again, I suspect this audience, you guys know that you probably use artificial intelligence applications every day, especially if you use this thing called a search engine. But in the context of gaming, more and more, and actually Frank talked about something rather interesting, the idea of giving an audience control of non-game characters, non-player characters. Well, if you don't have that, then why not use artificial intelligence to activate, to animate those non-game player characters and allow them to react when you're playing a game. So again, this is all about when you are doing something, when you're playing something, when you're engaged in something, what is it that pulls you in? And I'm going to argue that it's not the VR goggles themselves. That helps, certainly. It blocks out the rest of you guys, because if you're not interested in this is interesting. But that's not it, right? I mean, people get fully immersed in traditional display games or in your phone. So what is it that pulls you in? Well, that's what this is all about. That's what this industry is striving for. That's what we all are striving for, is to understand how do we do something different, hopefully. Something that is going to compel people to want to use either our game, our hardware, our solution, whatever that is. And as one example, when you play something and everything around you just has no awareness of you, okay, that's fun. When that environment starts reacting to the things you do, suddenly it starts feeling much more immersive and maybe a little more scary, because now you can't just blindly go shoot things. So the idea of incorporating AI into a gaming environment seems pretty obvious. From a technology standpoint, we have a line called Radeon Instinct, which is a focused really in the server context, but the underlying technology of Radeon Instinct and the engines that we develop in our GPUs will eventually or are being leveraged in the consumer space as well, through open standards, through efforts with partners across the ecosystem. So AI as a technology covers lots of different areas, but I did want to talk just briefly about this idea, other areas of interest within gaming. So not just this non-player character, but things like adaptive rendering. And these are concepts that many of our partners in the ecosystem are working on. So can you use AI instead of rendering the entire world? And as worlds get more and more complex, by the way, the rendering gets dramatically more complex. What if you had a way for an AI type engine to dynamically render elements of the environment so you didn't have to write code to do that? One, it makes developing games much, much easier, but two, it makes potentially creating and rendering them in real time much easier. The tracking concept. So everybody here has used VR. Please say yes. If you haven't, shame on you. So how many of you have used VR without a cable, without a wire? Either wireless or more importantly, has anybody used an inside-out tracking solution, whether it's cabled or not? Okay. So when you start looking at the ability to use AI to use camera data to map your environment, track your environment, and allow you to freely move around, again, is that something that you see as a user? Turns out no. But what you do realize is your freedom of movement is broadened. Objects in your environment are mapped, and you can move around them safely without taking the headset off. You can untether if you have that type of a setup. So there's all types of ways of using technology, not just things that you see like the game characters, but things that you don't necessarily see, things that we as technologists want to deliver because we know they make the world more engaging. And of course, there are many examples. Light and coloring rendering. Again, this is more about in an AR environment. How do you do something that with VR or even with traditional gaming, where you have an environment that's static, you're in a room. You've got windows, but you can set your display where you can see it. With AR, what if you're walking inside now? The lighting is dramatically different. You're seeing through I'm assuming a see-through type environment. That has to be adaptive. It has to know the environment that you're in. Even going between different areas of the room, the lighting can be dramatically different with an AR system. So lots of reasons, lots of opportunities to leverage artificial intelligence in that gaming environment. What about blockchain? By the way, before I just hit the button. Good. Before I go on, anybody have any ideas how you can leverage blockchain in gaming? I don't know if anybody's seen different announcements and stuff. You have, okay. All right. Anybody in here ever do crypto? Good for you. I didn't. Probably had opportunity lost. So what is blockchain? So basically, blockchain is a way to do secure transactions, secure tracking, various things. And by the way, I'm not the expert here, but essentially, it's an opportunity to have absolute awareness of whatever it is you're tracking or you're trying to manage and maintain. So as an underlying construct, that's great. What do games care about? Well, it turns out they care about a lot of things, much like all of these other industries care about. They care about the security of, or the gray market of their content being sold, or they care about you as a consumer. How do they engage you? How do you get somebody to want to continue to play your game or your series of games? Well, you give them awards, you give them credits they earn throughout playing the game, right? But then there's the question of how do you give them access to that over secure access of those credits when they upgrade to a new game or a different game that you've produced. There's not a good way to do that today. So we've been working a great deal with different industry leaders to enable these types of transactions to occur. So there are efforts going on where with distribution systems that employ a blockchain type of an architecture, the user, much like I guess maybe your social security number or your passport number, I don't know what, but there's a way to identify the user absolutely, so that when I buy a game, the system, the publisher can track me whether I'm playing game A, B, or C that I bought from that publisher. I still have the same credentials, same ID, and it's, I won't say unhackable, but most people in the blockchain industry argue that these types of architectures are unhackable, which means that I'm secure in my ability to take credits, earn credits, play games, and make certain that I maintain whatever status I have. And Frank just talked at length about how esports, and it's not just esports, not just professional teams, but esports in general, social gaming. You don't want to spend all that time and energy and then lose all your stuff because somebody hacked your account, right? So blockchain can have some real value to this industry. So in-game currency, but what about, as I just said, what about platform-wide? Well, then you get into this other idea of, I didn't have a slide for it, this other idea of, from a developer standpoint, and this is very, very attractive to the ISVs, to the game developers themselves. Today, when I buy a game and I'm finished with that and I want to move on, I might sell that game to somebody I know, right? The publisher gets no value from that resale. In fact, you could argue they lose value because the person who bought it didn't buy the game new. Well, I think I would tell you that in my experience, the publishers are not opposed to resale of games like that. What they want is essentially their fair share, right? If you go get a video from Hollywood, it has content protection built in. The idea being that you shouldn't be able to resell that without somehow, there's a revenue stream, there's an authentication streams throughout that. With blockchain, it becomes possible for people, for me, having played a game, to post that game back to the same publisher site and resell it and have the publisher share in that revenue, which means they promote the ability, they help with that ability. So they share in the revenue, and it makes it possible for me to move on and move on to the next thing that I want to do. So there's lots of initiatives or lots of value that comes from all this. Freesync Hdr. Freesync is a technology that is based on industry standards. And I will talk a bit through here that our focus as a company, we prefer and we drive towards open standards everywhere that we can. The goal being, the thinking being that the easier it is for developers, for communities, for users to adopt, the broader the market is. So Freesync as a standard is a standard that is a solution that allows for or prevents video tearing and stuttering of your game, of whatever you're playing. Actually, it could be video, it could be a game. But the beauty of it is that it's all based on open standards, and it enables this at no cost, because you don't have to go change your games, you don't have to go change anything. So we work aggressively, not with the game developers here, but actually with the monitor developers, to go and help them understand how to implement this, so that once it's employed, a user's experience is just enhanced. There's no changes, you don't have to turn it on, it just kind of works. HDR does actually require change, could require changes in the game. It doesn't have to. So HDR is just broadening your dynamic range of content and your ability to display that content. So again, with Freesync, you're simply delivering something seamlessly independent of changes to the industry. But then, and by the way, this was put into the Xbox Fair recently this past year. So, and on television. So there are TVs now, not just monitors, but many TVs now that are supporting Freesync as a technology as well. So that you can have this experience in your console level gaming as well as your PC gaming. But Freesync 2, which is an upgrade or a next step, I guess, to the Freesync technology, employs HDR. And the example, I was talking with somebody yesterday about this, the difference between HDR is one of those things that's very hard to explain if you haven't seen it, if you haven't used it much, to explain the value of it. The best way I can explain the value of it, think back to when you were watching, broadcast TV, 525 line broadcast, versus the 1080p that you're looking at now. Now that's difference in line resolution versus this is color depth. But if you can remember what displays look like, what TV broadcasts look like, and then you look at it today and you think, there's no way I'd go back. I would argue that at the point where we have enough critical mass on HDR, we'll think the same thing. We'll realize just how much immersion you get from seeing real world color depth versus what you get on a display today, okay? So HDR is all about being able to provide that, and hopefully be able to provide it seamless to the user. So the developers are putting in technologies to do this in the games. The monitor vendors are putting in support where necessary for things like low frame rate support, and this allows any kind of frame rate variance in the games to be fully masked through a technique like Freesync 2. And then XR. So XR is where I spend a lot of my time, a lot of my travel time. So as an industry, XR, VR, AR, mixed reality, kind of anything you want to wrap into that group. It's a new technology in that it's new enough. It's new because we now have the ability to deploy it in volume, in mass. It's clearly not a new technology. It's been around for decades, for some people argue since the 50s or 60s. But as a truly deployable technology, it's only in the past few years that it's become available to us. The compute technology, the CPU, the GPU compute technology behind it to drive it. So what is it that we do, and what is it that we see this industry, this opportunity for you guys as an organization? AMD spent the last 3 years, I guess, 3 or 4 years, developing dedicated driver architectures for our graphics, what we labeled Liquid VR, to specifically address the uniqueness of this immersive, this VR area, VR technology. You've got stereo imagery, you've got perceptual depth, you've got, the biggest challenge being latency. So all of this kind of work we put into our graphics drivers. And then the largest part of what you see here, we moved that, provided it in great detail in our original driver stack, and then we developed it, or provided it rather, to Microsoft as an element, or we work with Microsoft as an element to include in DX12. So a good deal of what you see there, saw in that list, is actually native now in DX12. So that game developers, it's just part of the environment that they get. That kind of progression, that kind of collaboration is key if we want broad adoption across an industry. Now, it didn't stop us from being innovative in the early days and putting all this stuff together. And hopefully we continue to do that with future developments. But again, as an industry, as an organization, the learning that we get by engaging that ecosystem, and hopefully what we get by engaging with you guys as a community, allows for that kind of continued progression, because that rate of progression is what is going to keep people interested. And then the last one, I will be brief on this because this is not an area I'm particularly familiar or expertise in, but ray tracing. So ray tracing is a big deal these days in so much as the desired outcome, more realistic environments, more realistic lighting and so forth. So with our Radeon Rays technology, we have the ability to do ray tracing asynchronous to the rest of the processing of the graphics engine. And of course, those rays, the outcome of that ray tracing can be leveraged initially for occlusion generation, for reflections, and then eventually for refraction to get you, a realistic type of an image. So ray tracing has a lot of value, but as with anything, there's a question of how best to leverage this, where does it get employed, and for what purposes. In some cases, when you're looking at truly realistic, like professional design and automation type environments, where you're trying to do lighting that is realistic for creating a car, creating an environment, this becomes a very valuable, immediately valuable and leverageable asset. When you look at gaming, we believe that this is going to be very strongly used in the gaming community. But it is a question of what does it bring in terms of pulling you in more, in terms of immersion. And so this is being employed along with all the other things around how do you get people to interact with you. The other part of ray tracing that I think people aren't necessarily aware of, anybody in here familiar with HRTF or perceptual sound, 3D sound? Okay, 3D, simple. It's been around for a while. Microsoft, I was working with Microsoft on 3D sound in 2000. That was a while ago. But it turns out that it doesn't work well when you have stereo speakers in front of you. Even with headphones, it didn't work very well because anytime you turn your head, the sound doesn't map properly. In VR, it works beautifully. It works phenomenally because your head is always tracked. Now that's assuming that your algorithms are processing properly. But the sound fields can in fact track your head movement exactly because you have head movement tracking solutions in the headset. So the concept of then taking the ray tracing architecture and applying that directly into the convolution engines for audio is also very attractive and very efficient in terms of processing power and so forth. So we're working heavily with audio engineers, with game engine engineers to employ this type of an architecture. And it's funny because I've been in the audio space for a lot of my career, and I will tell you that it's one of those things that when it's done right, people don't say anything nice. When it's done poorly, they will complain until you just leave the room. So, you don't get a lot of accolades out of doing this well, and yet the impact is truly visible. Unfortunately, it's visible by doing it poorly, but if you do it well, you can truly engage your audience much, much deeper than what we're seeing today in normal games. So, having said all that, each of these areas, as one example, by the way, but each of these areas play very well into a gaming market. Now, whether that gaming market is cloud, edge, or dedicated to your machine at home, more or less is irrelevant because each of these play the same role in those type of architectures. And in the end, what we would like and what we drive for is how to engage this community, this technology community, not end users, in these open standards and these initiatives, and get them, get the industry at large working together, working towards, open standards or community standards that can be leveraged. So our work towards that is published on GPU Open, and that's where we drive a lot of our partners. Okay, that's everything. I appreciate your time.